All right, for your Geometry 4.3 notes, we are learning two new postulates today of ways to prove that triangles are congruent. So today's are ASA, which stands for angle, side, angle, and AAS, which stands for angle, angle, side. So the first one is angle, side, angle. What it says is if two angles and the included side. So we talked a little bit about what the included side means. It means it's the side that's included or in between the two angles that are congruent. So it has to be the side that's in between. It can't be one of the other sides. It has to be the side that's in between the two angles that are also congruent to the other triangle, not to each other, but to the other triangle. All right, so what they're saying is if A is congruent to D, so A is congruent to D, and if side AC is congruent to side DF, and if angle C is congruent to angle F, then we have angle, side, angle. So the triangles are congruent by angle, side, angle. So this would be the statement, and this would be the statement, and this would be the reason. Okay, so which of the two triangles here are congruent by angle, side, angle? So it is not this one. And the reason it is not is because the side is not included. It's not between the two angles. So it is not this one. So it would be these two. All right, let's look at the next one. Which two triangles below are congruent by angle, side, angle? It is not this one. For this one to be it would have had to have been the side that's between the two angles. So angle, side, angle, angle, side, angle. Good. So it's these two. All right, the next one is angle, angle, side. So this is where the side is not in between. It's not included. Angle, side, angle would be if the side was between the two. But this one is just another side off on its own. So there are two angles and then a side, but the side is not in between, which is also why it's written like this. The one that it's written like this, it helps to point out that the side is included because it's between the two angles. On this one, the two angles are next to each other and then a side that's off on its own. Okay, so let's look down here if we were to write a proof using angle, angle, side. So we have statements on one side, reasons on the other, and they've already marked up everything that is given. So angle M and angle K, they're already marked up. Side WM is parallel to RK. So those are kind of hard to see, but those are parallel lines right here. And now we're just trying to prove that this triangle is congruent to this triangle. So let's try to prove it. First of all, what you should know is that WR is congruent to WR because it's the same in both triangles, which means it's reflexive. So let's go ahead and write that. WR is congruent to WR by reason of reflexive. That's the reflexive property. And then let's see what else we have. We have a side and an angle. A side and an angle. So we're going to need one more angle. So here's what you know about parallel lines. If these parallel lines were cut by a transversal, which it is, then all kinds of interesting angles are formed, like opposite interior, alternate interior, and others. But I'm looking at alternate interior because if this is the transversal and these are my two parallel lines, then that would mean this angle would have to be congruent to this angle because of alternate interior angles. So let's go ahead and write what that one is. So KWR, angle KWR, is congruent to angle MRW, and the reason is alternate interior angles. Okay, and now that we have a side and then two angles and a side and two angles, we can go ahead and be done. We can say now that we have proven that triangle WMR is congruent to triangle RKW, that's a K, And the reason is because of angle, angle, side. So the side is not included between the two angles. So it is angle, angle, side. All right, let's turn it over to the back. This is basically a yes or no question, but we do need to talk about why. So are triangle PAR and triangle SIR congruent? So what you should know is that these are vertical angles, and vertical angles are going to also be congruent. And now we have an angle, angle, and a side. An angle, an angle, and a side. So this is going to be yes. And the reason is because we've done two things. We talked about vertical angles are congruent. And then after we mark up that vertical angles are congruent, we have proven it by angle, angle, side postulate. So I'm going to put and angle, angle, side. All right, let's do a quick lesson check. If there was a triangle RST, let's go ahead and draw it out. It helps to see a picture. So RST. In triangle RST, which side is included? Remember, included means kind of in between angle R and angle S. So here's angle R, here's angle S. The side that's between would be side RS. It helps to draw a picture. Okay, in triangle NOM. So here's another one, NOM. Side length NO, so that's this one, is included between which angles? So it is between angle N and angle O. Angle N and angle O. And then the last question, which postulate or theorem could you use to prove that these two are congruent, and then down here that these two are congruent? So this one looks like angle, side, angle, angle, side, angle. So this is angle, side, angle. And this one is angle, angle, side, angle, angle, side.